In this section, we'll be looking at data interaction and visualization. This is how the data is distributed, how the data looks like when you visualize it in charts. In this video, we're going to look at efficient distribution of the data. First, we're going to look at the mean. Mean is a measure of central tendency, and to calculate the mean, add the values in a data set and then divide by the number of all the values. Second, we're going to look at the median. Median is a measure of central tendency, and median is the middle value in a data set arranged from the smallest to the largest. If the number is an odd number, median will be the middle value. If all the numbers are even, median will be the average of the two numbers at the middle. Next, we'll look at the maximum and the minimum. The maximum is the largest number in a data set, which is arranged from the smallest to the largest, while minimum is the smallest number in a data set arranged from smallest to the largest. In execution, we're going to focus on 3 steps. In the first step, we're going to get the mean, the max in the different data sets. Let's see how we do it in Java. We're going to be using the data sets, the diabetes data set, and the first thing is to load it in the table called diabetes data. Second is to get the structure so that we familiarize ourselves with the dimensions within the data. Let's run and see. The data sets comprises of 9 columns, age, sex, BMI, called diabetes data, or of type double. Next, we'll be retrieving the columns that we will be using to calculate the minimum and the maximum. We'll be using the age column, and we are also going to use the BMI column. We can name this BMI. Once we retrieve the columns, the next thing is to calculate the minimum and the maximum. From our diabetes data, we are going to summarize the column that we extracted, and you're going to get the minimum and the maximum. The summarize function, it takes more than 3, it takes 5 variables, where the first is the column, is the data set, and then you can list the measures of the tendency that you want to calculate. In our scenario, we just have minimum and a maximum, and we're going to print out the distribution. Let's run and see. In looking at the data set, the minimum age is 19 and the maximum age is 79. We can also look at the minimum and the maximum of the BMI data. In looking at the data set, in the BMI, the minimum BMI is 18 and the maximum is 42. That's how we calculate the minimum and the maximum. In the second step, we'll be looking at the average and the median in the data set. We'll be using the BMI distribution. We can just name it BMI2. We'll look at the BMI data, and we're going to pass the BMI column and what we want to calculate. .summarize function, you just need to give it column and the measures of tendency. Let's see the median and the mean in the BMI data set. The mean in the BMI is 26.37 and the median is 25.7. If we wanted to use the age, we could have just passed the age column here. The next one is looking at getting the mean by something else. For example, the mean of the age by sex. We are looking at the age, we'll be looking at the mean, max, mean, and median by sex, and we will print it out. We have been able to get at the mean by sex. The mean age for female is 46, the mean age for male is 50. The same case, the maximum age for female is 75 and the maximum age for male is 79. In step 3, understanding the results and grouping by different parameters. We have already grouped by one parameter, which is sex, and looking at the results, we can be able to see what is the mean of women, what is the mean age of men. We could have added something different, for example, BMI, and let's see. Since the numbers are so many, it will be hard for us to understand the distribution. It was easy to get with sex since it's only male and female. For more references, check at Table Cell Library.